For the second problem set, we'll be looking at the partition walls that are going to be utilized for the interior walls that are non-load bearing, as well as the exterior wall sheathing. So we'll have to calculate a system of wall and floor heights before we can actually figure out what the number of sheets are going to be. So to start off with, we need to look at the lineal foot of walls parallel to the floor joists. This drawing is posted to Blackboard Learn. And this is explaining why we're even looking at the numbers related to the walls parallel to the floor joists. So there is one wall highlighted in green, and this is the wall that's for the stairwell. This one is not going to be included in our calculations because we absolutely know that there is a double joist underneath from our previous calculations, so we don't have to worry about this wall here. But the rest of these walls that are parallel to the floor joists, we have our floor joists running from front to the back of the house. We don't know where those joists lie underneath our walls. If we did the actual layout, we would be able to figure it out. But since we're not going to go through that, we're just going to calculate for all of them and add blocking where needed. For example, if we have these common joists that happen to run on either side of this wall that divides the bathroom and bedroom, if we didn't have a joist underneath that sheathing, when we nailed down through the bottom plate, we would just nail into the 3/4 inch sheathing that is the floor system and not into something more structurally sound. So even though it's not load bearing, we want to make sure that it is strong and will stand up against any forces that might act on it. So what we will put underneath it is blocking. So once we have our floor joists running parallel to each other, we will add blocking to make it look like a ladder underneath, and this is going to be perpendicular to our wall. So what we're trying to calculate then is how many of these blocks we need. The blocking spacing is 16 inches on center. This happens to be the same spacing as our floor joist, but make note that is not always the case, so you want to make sure that you read what the directions are for that blocking. So first off, we need to calculate all of our floor joists that are parallel to the walls, all the walls that are parallel to the floor joists. We can simplify our calculations. We have 3 walls on the front that all appear to be the same 11 feet. We have 2 in the back, doesn't matter whether it's a 2x6 or a 2x4 wall. Both, as long as they're parallel, will run underneath. So we will see that both of those are approximately the 10'9". Plus we have our 2-foot wall that is the side of the closet, and another 4 foot approximately, again, due to our 2'1" depth. Again, it could be closer to 4.5, but for simplicity's sake, we're going to leave it at 2 and 4. So doing the calculation for number 18, looking at just the lineal foot of walls parallel to the floor joists, we have our 2 walls up top, between the kitchen and the bathroom, and then between the bathroom and the bedroom that are both 10.75 feet, that 10'9". We have the 3 walls up front that are all 11 feet between the closets and living room, closets and bedroom, and between the 2 bedrooms. The 2 foot that is the side of the linen closet in the hallway, and the 4 foot that's the side of the closets in the bedrooms. If we total all that up, we have 60.5 feet. And that is the lineal footage parallel to our floor system. So if we look back at our sample problem, we're now using this to calculate our solid blocking. Again, this is where it tells us that the spacing is 16 inches on center. It is not telling us in the specifications, so we need to make sure we get that information elsewhere. We are calculating the quantity of 14.5 inch solid blocking. So that's the length in between the 16 inch on center. At this point, we are not calculating the lineal foot of blocking, we're just calculating the quantity. So it's a repetitive item, just like we've done before. We have 60.5 feet, which we just calculated number 18. We divide that by the 16 inch spacing. We make sure to change that into feet. So we have feet divided by feet, gives us 45.376. Again, we always round up, so we have a whole number, and we end up with 46 spaces. At this point, we don't want to just add one because this is not a full long wall that is 60.5 feet. It is multiple walls that we need to close off. So what we're going to add is one per wall. We can look back at our drawing. We can see that we have the ones highlighted in pink, 1, 2, 3 across the front, 4, 5, 6 in the back, and the 7th one. So total we have 7 walls. So 7 walls means we have 46 from our spaces, plus the 7 walls, we have 53 solid blocking pieces that we need between our floor joists for all the walls that are parallel to our floor system. So till we figure out what the actual layout is, we can use this as our count to figure out what the lineal footage and then what the board foot is. But at this point we're going to stop there and switch over to our wall height. So we need to calculate the components of our wall system and our floor system so that we can figure out what the total wall height is when we are putting our exterior sheathing on the outside of our home. So we, for our wall system, have a double 2x4 top plate. We have our 2x4 stud, which makes for our ceiling height, and I'll explain that in just a moment. Single bottom plate, and those components make up our wall height. Our floor height then is our 3/4 inch tongue and groove. We have our 2x8 joist or 2x8 band board that goes around the outside, and then the 2x6 treated sill plate. There will be 1 inch of overlap on the foundation, which we will add once we total everything up. But for now, in the next one, we're looking just at our floor system. So number 20 asks for the height of the floor system only. And this is where we have our 3/4 inch floor sheathing. So floor sheathing is 3/4 inch. We have that sitting on top of a joist or a band joist, depending on where we're at in the foundation system, which is 2x8, and that sits on top of a 2x6 sill plate. You want to make sure that you're paying attention to how the boards are oriented. So our band joists and joists are up on end, so the number we care about is the second number, and remember 2x8, the actual height or thickness of a 2x8 is 7.25 inches, but our sill plate, since it's laying flat, we care about the first number, and the actual for a 2x is 1.5 inches. So you need to make sure that you're using the correct numbers when you add it up. So we have 3/4 inch for our floor sheathing, we have 7.25 inch for our band joists, and we have 1.5 inch for our wall system, sorry, our sill plate. We have a total of 9.5 inches. You can leave that in your inches, you can convert it to feet. Since it's less than a foot, leaving it in inches is perfectly acceptable. I'm going to go to the next page for our wall system so that we can calculate. I can show you how these numbers are calculated. So when we're talking about the wall, this is everything from the floor sheathing up. And this is where I want to explain how we can end up with an 8-foot ceiling height when we use studs that are 92 5/8 inch. This is considered a pre-cut stud. We need to make sure that we use this whenever we're using an 8-foot ceiling height. Remember from the first problem set we discussed that a 9-foot ceiling height would require 104 5/8. The reason why is from our wall system, which we just said, we have our top plate, which is a double top plate. So when we have our 2 plates sitting on end, total, that is 3 inches in thickness. The stud height as we said, 92 5/8 in length. It is sitting on end. And then we have our bottom plate. We have a single bottom plate, so it's just one on end. That's the 1.5 inches. If we total all of that up, we would get 8 foot, 1 1/8 inch. How we get down to the 8 foot ceiling height then is we have to account for the ceiling. We'll add drywall to the ceiling, which is typically 5/8 inch per fire code. And then we'll have our flooring that will sit on top of the sheathing that will also reduce. So this is subtracting 5/8 from the total. And though flooring thicknesses can be different depending on whether you're using vinyl or tile or hardwood or carpet, in general, if we just account for 1/2 inch of flooring, we can subtract out that inch and 1/8, and that is how we are left with an 8 foot ceiling height. So anytime we want a clear 8 feet, we need to use a stud that is 92 5/8 inch. So that is why we have the pre-cut studs. So if we total up the double top plate, the stud, and the bottom plate, as I just showed, it is the 8 foot 1 1/8 inch. Or if we did leave it in inches, it is 97 1/8 total in inches, but typically we write in feet and inches when it is anything over a foot. From that, we can total our floor and our wall. So we have the 9.5, that is the floor. I'm going to add the inches for the wall and then convert at the end. But we also have that 1 inch of overlap. So where the wall sheathing needs to come down from the wall and cover where that potential gap is from the sill plate to the foundation wall, we want the 1 inch of overlap. So that is 107 5/8, and then converted into feet, that is 8 feet 11 5/8 inch. The last few steps look at the sheathing then that we need. So we need our exterior perimeter, which we have calculated many times before. That is going to be our 124 feet. We multiply that by the 8 feet 11 5/8 that we just determined for our full wall and floor system height, and we get 1112.125. We can leave in decimal form if we want, or we can round up to the nearest whole number for square footage for our exterior perimeter. We have the vertical square footage now. I'm going to use the unrounded number in my future calculations. We divide it by 32 square feet. Remember, the standard OSB plywood, any board size is typically 4 foot by 8 feet, so it is the 32 square feet, which is 34.75. Here we have to round up to the nearest whole number because it's a counted item. We need 35 sheets of plywood to be able to cover the entire exterior of the home for our wall sheathing. And that concludes the second problem set.